Greetings. I hope I find you well. Would like to thank God for this opportunity once again. We are still on vectors, and this is now video number 2. Okay, last time we looked into properties of shapes as far as vectors are concerned, but now we've moved on to the second subheading in vectors. This is IGCSE mathematics, or O-level mathematics to some. Okay, so in this video we are looking into, like, for example, shapes that are outside the Cartesian plane. The Cartesian plane is the XY diagram. So we defined a vector previously and say a vector is a quantity which shows magnitude and direction. I'm going to highlight these two keywords, magnitude as well as direction. These are very important. Okay, so we also say that the opposite of a vector is the scalar. The scalar is the opposite of a vector, and last time I've shown you on how to multiply the scalar quantity. And also, if you remember from the first video, we also looked into addition and subtraction of vectors. Alright, still remember this. Now, we want to talk about shapes now that are outside the Cartesian plane. So let's look at these shapes. Alright, for example, if I'm to draw a shape, this is a trapezium. A trapezium is a four-sided shape with opposite sides parallel. Something like this. So this is a sketch diagram of the trapezium. And in this trapezium we are given sides, and we are given this side as 4b, and this one as 2a, and this one as 8b, and this is a value which is known as e. This value is known as e. Okay. So E is a point, or it shows the distance between A, C. So AC is a vector indicated by the arrow, if you still remember from the last videos. We also have an arrow which shows OA, and this is OA, OC, and also there is B here. Alright, so from this, there are things that we can actually deduce from this trapezium. So this trapezium is not drawn to scale, alright? But we've been told that this distance from A to B, which we can indicate in vector form as AB, is equal to 4B. And the distance of OA, remember how to represent vectors, we use this arrow. There are so many ways, but this is the most common way of representing a vector. This is equal to 2A. And this OC is equals to 8B. Right. So for example, if you ask it to calculate, I'm going to clear the space here and be able to answer the questions. How do we find the vectors in terms of A and B? In terms of A and B, in this case, we're looking at small letter A and small letter B. So this is how we represent it. Okay. I want to go to OB. Okay. From O to B. That's where I want to go. So if I want to go from O to B, I have to pass through OA, then AB, right? Can you see that? I have to pass from OA to AB if I want to go to OB, all right? Suppose there's a place called O and there's a place called B. Then I want to go from O to B, I have to go via another place called A. So it is always in A, small letter A and small letter B. Remember, that's what the examiner wants us to do, to represent in the form of small letter A and small letter B. Okay. So look closely in the calculation to my far right. OB is indicated by this dotted line, and it's a vector which is showing this direction. So I have to go through OB is equals to OA plus AB. Okay, check the arrow. This will be equal to OA is equals to 2A, then AB is equals to 4B. So we know A and B, we can go further in this one. So this is how you find OB. Okay, so before we close, let's look at another one. Maybe let's look at how do we find AC? Okay, AC is indicated by this E, which is a blue line. AC, let's look at AC. Vector AC is equal to AO. Remember, we are going this direction now. A to C, then it's AO, then O to C. AO plus OC. I hope you can see this clearly from this far right. Okay, now we know AO. AO is the reverse of the arrow. So we put a negative. Negative 2A plus, because this is flowing with the arrow, OC, we just write as positive 8B. Right, so this is the answer. But it is always advised to leave your answer in positive form first. Start with the positive numbers. So we're going to write 8B minus 2A, which is going to be the answer. All right, thank you very much. Let's look at more questions in vectors and be able to use this property of shape method to solve vectors. God bless you. Goodbye.